Hello from Chem Help ASAP. Let's see how kinetics are relevant to the SN1 and E1 reactions. On the left of the screen, we have two model reactions. The top one is an SN1. The bottom one is an E1. A representative reaction coordinate diagram for both reactions is in the upper right. Energetically, both reactions look very similar. Why do they look the same? Well, both are two-step processes with a common intermediate, carbocation. The one in SN1 and E1 indicates that the reaction is unimolecular in the rate-determining step. Okay, but we have two steps. Which is the rate-determining step? Would that be the first or the second? The rate-determining step is always the step with the highest energy transition state. Here are the two transition states. And the first one is the one with higher energy. So the first mechanistic step is the rate-determining step. Great, but how are these reactions unimolecular in the rate-determining step? Let's focus on the SN1. In the first step, we'll show the mechanism. The halide, the alkyl halide ionizes. The CCl bond breaks to form a carbocation. The rate of the reaction depends only upon the concentration of the alkyl halide. Here is the rate equation. So rate equals K, that's a lowercase k, our rate constant, times the concentration of our alkyl halide. Note that the reaction described by this equation has an overall reaction order of 1. Does that mean that the concentration of the nucleophile, sodium iodide, does not affect the rate of the SN1 reaction? Yes, that's exactly what this equation is saying. The difficult step in the reaction is making the carbocation. Attacking the carbocation is relatively easy. To make this point more clear, we can insert the nucleophile, sodium iodide, into the rate equation. So just below, we could write rate equals the rate constant times the concentration of alkyl halide times the concentration of iodide, our nucleophile. Now, if we do this, we'll need to add it in a way so that it has no effect on the rate. We can do it if we give sodium iodide, or iodide, an exponent of 0. So that term has a value of 1. The reaction is 0 order in iodide. The overall reaction order in this new equation is still 1. That's the sum of the exponents. There's just 1. Based on this new equation, just like the previous one, changes to the concentration of sodium iodide have no effect on the reaction rate. If a reaction's rate is 0 order in one of the reagents, then that reagent, which may still be required for the reaction, does not participate in the rate-determining step. So, both the SN1 and E1 reactions are first order in the rate-determining step, and the rate depends only on the concentration of the alkyl halide.